Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the synthesis of some of the carboxylic acid by using malonic ester. That is the point we are discussing. So by using that, because we are learning or we are discussing the synthetic application, and as we know that malonic ester is one of the synthetic reagent and it is a versatile reagent. Versatile means what? Variety of the organic compound we can synthesize by using that ester, because that if you look at the structure of malonic ester, it has CH2 group, that is methylene group, and that methylene group is known as a reactive methylene group. And why it is a termed or why it is called as a reactive methylene group? The reason behind it, that methylene group is present or it is flanked between two strong electron withdrawing group, and that's why it is called as a reactive methylene group. And whatever hydrogen atom present on it, they are highly acidic in nature. By using the bases, that acid, that proton get abstracted, forming or leaving the carbanion. And as we know that carbanion are the nucleophilic in nature, and that nucleophile can attack on a electrophile. There is a formation of the new carbon-carbon bond, covalent bonds are formed, and therefore synthetically it is very important one as far as organic chemistry is concerned. So far we have seen 4-5 example. Starting from the malonic ester, we have synthesized different type of the substituted acid, means alpha substituted acid we have prepared, and how to plan, how to recognize, how to synthesize that target molecule. Starting from the malonic ester, that are the thing we are learning. Let us see here, look at on the blackboard. What is their synthesis of gamma dicarboxylic acid? So far we have learned, we have synthesized monocarboxylic acid, alpha substituted monocarboxylic acid, or that are the compound we have synthesized. Now we are going to synthesize the synthesis of gamma dicarboxylic acid, starting or using from the malonic ester. Or the question may arise, in an exam, or the question may going to ask in an exam like this: how will you prepare dicarboxylic acid in the laboratory using malonic ester? So let us see here, synthesis of gamma dicarboxylic acid, or the this one, the 2 moles of malonic ester condensed with CH2I2, means methyl diiodide, to form first a tetraester, and which on hydrolysis and decarboxylation produce a gamma dicarboxylic acid. That is the simplest method to synthesize, to prepare that tetra acid in the laboratory, and after the decarboxylation we are going to get the compound, that is a glutamic acid. Let us see here, I am writing that is a how do I prepare dicarboxylic acid in the laboratory starting from the malonic ester. Suppose I have taken here the as we know that everyone knows that the structure of the malonic ester, ETO, then C double bond O, then CH2, then C double bond O, ET. Here we have used, this is a malonic ester. This is the structure of malonic ester, and this malonic ester further treated with here I have taken as a 2 moles of Melonic ester that will be treated with the 2 moles of sodium ethoxide. What I am going to get over there for suitability, I am writing this Melonic ester structure in such a way that so that you can understand this is a first, and then we are going to treat this one I then CH2 iodine, that is a double alkylation type of the reaction. So what you are going to get over here, so that let us see first here 2 moles of sodium ethoxides are used. Here I am writing here CH2, then C double bond O ET, here C double bond O, then ET O. This is the structure I am writing over there. Sorry, here is a negative charge, then iodine, another one CH2 iodine, and plus this CH minus charge, then C double bond O, then OET, again this is a carbon atom, again here C double bond OET. That 2 molecule after the attack of that sodium alkoxide, it produce this type of the carbanion, and that is going to attack over there here elimination of iodine. This is attacking over there elimination of iodine, and the resulting compound formed will be this one, this CH, then middle one this CH2, then CH, now C double bond OET, and here I am writing C double bond OET specifically in the same way this C double bond O, then OET, here also C double bond O and OET, right? That is called as a tetraacetate ester. This is a tetraacetate you can call it as, or you can call it as a tetra ester you can call it as a tetra ester, means 4 groups are there, and therefore we can call it as a tetra ester. And after getting as a tetra ester, what is the next procedure or what is the next step to do here? You have to hydrolyze it H2O in presence of H plus. Here also has a 2 moles required for hydrolysis. This 4, all that ester group, this process is known as a hydrolysis. Ester group is get converted into acid, and you are going to get here CH2, then CH, I am writing C double bond OH, here C double bond O and H, and here also this side CH, then C double bond O, here OH, I am writing over here, then C double bond O and H over here. So one of them I am writing for suitability, so you can see clearly the 4, and therefore it is called as a tetra acid now, right? This will be the tetra acid. Got it? After that, what will be the next step? Next step will be the decarboxylation, and here just heating it, you are going to get 2 moles of carbon dioxide get removed over there. Look at here how it is going to remove over here, and this is now this revolving around it and negative charge forming over that, and here you are going to get the product here HO, then C double bond O, then CH minus charge over there, this middle one CH2, then CH minus charge C double bond O, and then OH. There are 2 carbanion, and then again protonation. You can do the protonation over here, and as we know that protonation and the hydrolysis, the reagent we can use as the same H2O and H plus. What you are going to get here, this carbanion will pick up the proton from here, and that's why this process is known as protonation, and finally you are going to get HO, then C double bond O, then CH2, CH2, C double bond O, and OH. Not I think one more CH2 you have to insert over there. Here is a CH2, then C double bond O and OH. This is a dicarboxylic acid we have got over here, and in this way we have prepared the desired product of the carboxylic dicarboxylic acid, and this one is known as a pentane 5 dicarboxylic acid. 1, 2, 3, 4 and 5. So this pentane 5 carbon atom in the straight chain, and therefore we can call it as a pentane. And pentane and 1 5 are 5 dicarboxylic acid. Dicarboxylic acid. So that will be the IUPAC, probable IUPAC name of this compound, or what we can call it as the common name of this compound is a glutamic acid. The common name of this compound is a glutamic acid. This will be the common name of that compound. So in this way we have synthesized the dicarboxylic acid in the laboratory, starting from the malonic ester. And now let us look at as a next one, synthesis of succinic acid. Now we are going to see the next application, synthetic application of that malonic ester, because we are discussing the synthesis of various acid starting from the malonic ester. So now what we are going to synthesize? Synthesis of succinic acid. Synthesis of succinic acid. Succinic acid. Synthesis of succinic acid. And you know that the acid, there are the various acids are generally we are using the succinic acid. The structure of that succinic acid you should if you know, then and then you can able to synthesize that compound in the laboratory. How do you synthesize that succinic acid? Let us see here. The structure of succinic acid will be this one, here HO, then C double bond O, CH2, CH2 and C double bond O, OH. This will be the structure of succinic acid. And suppose as this structure, let me show over here, C double bond O, then CH2, then C double bond O, OH, and I am writing HO, then C double bond O, then C double bond O, OH. All are the dicarboxylic. These are the example of dicarboxylic acid, and this HC double bond, this one is called as the oxalic acid. Do you remember this one, oxalic acid? And this one is known as a malonic acid. This is a malonic acid, and this one is called as a succinic acid. Succinic acid, all are the dicarboxylic acid, and as we know that acidity of that dicarboxylic acid are generally greater as compared to as a monocarboxylic acid. So that are the strength of acidity and basicity we have learned in a third semester. Here just we are learning the what we can call it as a synthesis of that carboxylic acid. Now how will you prepare this succinic acid starting from the malonic ester? As we know that the starting compound of for this synthesis, again we have to use as a succinic acid. The question may arise in the exam, how will you synthesize succinic acid using malonic ester? So there you have to take as a starting compound as a malonic ester, and then add the suitable reagent and arrive or reach to that desired product. So that is that thing is called as a planning. This is they have given us the target molecule is this one. Succinic acid is a target molecule is given to you, and they are showing, they are mentioning that you have to synthesize this target molecule by using the starting material is a malonic ester. So you should not prepare this, because there are the different ways. There are the different starting material. By using as a different starting material, we can prepare this one. But here in this particular, the aim of this chapter, you have to think, you have to prepare that particular product by using the starting compound is a malonic ester. Only two synthetic reagents we are going to use here. One is a malonic ester, another one is a acetoacetic ester, and finally we will see the Wittig reaction. These are the important reaction. All these reactions are proceeding via the Carbanions. So let us begin the synthesis of succinic acid. Let us see here malonic ester. We know that the structure of malonic ester is this one, ETO, then C double bond O, then CH2, C double bond O, then OET, right? This is the structure of malonic ester. This is the structure of malonic ester, and this structure or this malonic ester add slowly the sodium ethoxide. NaOET, sodium ethoxide is generally used as a base. The function of base to abstract the acidic proton, and finally what you are going to get is a Carbanion over there. And now this is a reactive methylene group or the acidic group, where you are going to get ETO, then C double bond O, then CH minus charge, C double bond O, and OET. Here you can put as a Na plus. If you mention there Na plus, or if you don't mention, it doesn't make any difference over here. And now this will be treated with this one, Br, then CH2, C double bond O, and OET. This is called as a alpha bromo ester. So this will be used here as a material. So what is going to happen here? And this negative charge is going to attack on this Br. Then Br get removed over there. You are going to get is a triester here. ETO, then C double bond O, then CH, I am writing this one, CH2, then C double bond O, OET, another one, this one, C double bond O, then OET. This is called as a triester. Triester in a previous example we have seen as a tetraester. Now we have got as a triester, right? Triester means why triester? There are the three ester groups are there, and that's why we can call it as a triester. And now here, what is our next step? The next step will be the hydrolysis. H2O in presence of H plus. This process is known as a hydrolysis. And hydrolysis, after the hydrolysis, what do you mean by the hydrolysis? Hydrolysis is a process which can convert ester group into as a acid. There are the three ester group. If you observe this structure carefully, you will notice there, you will see there are the three ester groups are there. All these three groups get converted into acid like this. Let me write that acids here, HO, then C double bond O, then CH, right? And then writing here C double bond O, then OH, and another one I am writing over here is this one CH2, then writing as a C double bond O and OH, right? So this is the thing I have written over here. Now what will be the next step? You might be knowing this next step. What will be the next step? Next step will be the decarboxylation, right? What is going to happen in the decarboxylation? Just heat it, there is a elimination of carbon dioxide, and that process is known as a decarboxylation, and this process is known as a decarboxylation. And after the decarboxylation, how this decarboxylation can be done? It will be showing like this, negative charge. Look at the arrow. This sigma bond forming as a double bond with that oxygen. This double bond retain means it remains as it is, and this bond is broken from here and forming as a negative charge on this particular carbon atom. And look at this acid group and this acid group, other part remains as it is, and finally here you are going to get negative charge. It is just like as a carbanion OA, C double bond OH, and then here you can write CH2, then C double bond O and OH. And when this carbanion will pick up the proton from acid, here H2O from the hydronium ion, and this species we can also write in this manner, CH3O plus, like this. And or for sake of mechanism, we can show this one like this, H then H positive charge over there. This can pick up the proton from here, this neutralizing that positive charge, and finally what you are going to get, this compound we are going to get here CH2, then C double bond O, OH, and then here again as a CH2, C double bond O, OH. If you observe, if you notice this structure carefully while planning, how do you, suppose I am writing here is one of the hydrogen atom for suitability, and I am mentioning blocking this group square bracket. This part, from where this part is coming, do you remember? This part is coming from the Melonic Ester. Remember this CH, C double bond OH, this part is coming from the Melonic Ester. And now if you see over here, this part, another carboxylic group CH2 C double bond O, I am marking over here, this is coming from the alpha bromo ester. Remember this part is coming from the alpha bromo ester, and therefore we have got as this type of the compound. Understood this one? So in this way we have prepared, we have seen number of example, we have synthesized monocarboxylic acid as well as dicarboxylic acid. Starting compound we have used here in this particular reaction is the what is that? Melonic ester, and as we know that Melonic ester is a versatile synthon, variety of the organic compound we can prepare, we can synthesize by using that Melonic ester, and that's why at a T.Y.B.Sc level this concept is introduced. So it is a very useful concept as far as a research point of view is concerned. In a future you can see, you can plan the synthesis, how you can synthesize the different new organic compound by using this type of the strategies, because these strategies are mainly helping in your future research point of view is concerned. So I think we have learned number of we have considered as a number of example by using as a starting compound is a malonic ester which has a reactive methylene group. 1 mark question may appear in an exam. What is reactive methylene group? So in this way, or 3 mark question or 2 mark question may appear in the exam. How the nature of that question? The nature of that question may be like this. Suppose, how will you prepare the succinic acid in the laboratory using the malonic ester, or how will you prepare the propionic acid using malonic ester, or how will you prepare the 2-methyl butanoic acid using malonic ester, or starting from the malonic ester, how will you prepare the cyclopentane carboxylic acid, or the question may be like this: how will you prepare the cyclobutane carboxylic acid using malonic ester? So I think with this we have completed this malonic most of the example with the suitable example we have taken, and in the next lecture we are going to consider the next synthetic reagent. Why they are called as a synthetic reagent? Because they have one special group that is called as the reactive methylene group, CH2, in acetoacetic ester. Next synthetic reagent we are going to use, and that acetoacetic ester we already familiar with this reagent, because this reagent ethyl acetoacetate or the acetoacetic ester or beta keto ester, which is synthesized by using as a Claisen ester condensation, which is one of the famous reaction. By using that we have prepared, and that reagent we are going to use as a synthetic, and their synthetic application we are going to learn in a next lecture. I think with this, let us stop today here. Have a nice day. Thank you.